Dear ladies and gentlemen, welcome to another episode of our podcast, Power On. My name is Christian Schaider, and our today's topic is insulating liquids and DGA sensors. DGA stands for dissolved gas analysis. Insulating liquid is in most power transformers and has four main areas what it can do. So all provides first dielectrical strength. So it acts as a dielectrical and as an insulating material. Second, all provides heat transfer from the winding to the outside to the coolers. All protects the solid insulation, so acts as a barrier between the paper and the damaging effects of oxygen and moisture. Third, all can be tested. And I'm happy to welcome my guest, Oliver Reetz, which is an expert in that specific area. Hi, Oliver.
Hi, Christian. Thank you for having me here.
Oliver, when was your first touch point with the topic insulating oil, DGA topics in the area of a power transformer?
That's a good question, because this is already pretty long time ago when I came first in touch with insulating liquid and so on. Started with MR about 20 years ago. The first thing what I got to know is that there is an on-load tap changer which is usually installed in a regulated power transformer, and obviously also these on-load tap changers are immersed with certain oil, insulating oil, exactly for the reasons what you just mentioned already. So first of all, for insulation, for lubrication, which is different to a transformer, but as well for cooling. So this is the first time when I came along with this kind of liquids, and also the first talks with customers over there, or with, let's say, different kind of persons which we were talking, because most of them didn't even know how a tap changer looks like, because where are we delivering a tap changer to as a transformer manufacturer? They are installing it, and the first time they get in contact with these tap changers is when these tap changers needs to be serviced from their own service personnel or by any service contractor over there. And one of the major points what you're doing as well during the service of a tap changer is that you're replacing as well the insulation oil. And in periodical cases as well, you need to measure the breakdown voltage as well from the insulation oil within the OLTC, in order to assure that the dielectric strength is always given, which is foreseen in the manual of each individual tap changer. And so I came along from the OLTC to the transformer, and then, of course, once you're there and you're talking with different persons, the service manager, the asset manager over there, you come also in talks also in regard of the transformer and insulation liquid as well, which is in the transformer.
Right. So the IEC specifications, they describe how to test the oil for a tap changer, and of course there are also some standards to test the oil inside a transformer. If I understood that right, this is how you came along with this interesting topic.
Exactly, Christian. This is the major point. I mean, it's like there are studies as well from CIGRE which are saying that 45% of transformer failures might be caused due to the active part, which is in the transformer. And as one of the major feature of the oil within the transformer is the purpose of insulating, cooling, and the protection as well for the cellulose paper. So the question is how to find out if there's an issue within the active part of the transformer. And that is the reason why on a periodical cases, oil samples are taken from the transformer. Usually, and this is like it is done for plenty of years right now, is that once in a year, twice, depending on the allocation of the personnel, depending on the time and on the criticality of the transformers, asset managers taking these oil samples, taking them to the oil laboratory, and there a further investigation analysis is going to be done. This is a regular procedure, how asset managers and how the, let's say, the strategical asset management is allocated in order to assure a proper operation and a certain health condition of the transformer.
Right. So I have then globally different standards depending on the transformer criticality and to the individual asset strategy. The oil sample is taken, sent to a laboratory. So I know then the condition of this transformer when I took the oil sample. But what is in the the meantime happening with this transformer when I would say I take it twice a year or once a year, then I have 364 days without knowing anything, I would assume, right? Or is there any option possibility what I can do?
This is exactly the downturn of having this kind of periodical oil samples taking, which is a good thing on the one hand side. You have a certain trend which you can allocate, which you know, and which you can also document over there. But the uncertainty between the intervals when you take an oil sample, this is given. I always compare this when I get asked, and then I'm in touch and talking with different people. It's like, compare it like when you go to a doctor. You give a blood sample, and based on the blood sample, the doctor will tell you about, your iron value is like this value is like this, and then it will tell you the certain condition of your body. And you take it for granted in the next 364 days. Usually you're not going there and say, okay, I'm fit, everything is all right. And then after 1 year, you take the next blood sample, and then he says, okay, look, there is an issue, but we should have known this before, then we could have acted already. And that is exactly where we come into the into the issue and the challenges which asset managers have. On the one hand side, they know, okay, look, if I take it more often, the oil sample, then I have a better trend analysis. On the other side, they don't have the staff, they don't have the personnel, the logistics, and it costs you also a lot of money in order to allocate. Yeah,
I have to go there, take the oil sample, send it to the lab. Okay,
exactly. And one more reason is that, like, when you take the oil sample, it's not trivial that you just say, okay, look, I go there, drain the oil into any bottle over there, and then send it somewhere. I mean, you have to consider that taking the oil sample is a skill. That means when nowadays when I see tenders from utilities from companies who would like to take oil samples of the transformer, they write clearly that the people are supposed to be very experienced. They should have taken the oil samples of at least 1,000 transformers, because you need to know exactly how you do it. Because the most critical point is at the time when you take the oil sample, then about the temperature, when you transport this then to the laboratory, you have to do it within a couple of days. I mean, these all have an effect, and therefore they also come into a certain conflict. Say, okay, look, if I take it even more often, just offline over there, then there's a risk higher. And isn't there another solution rather than taking the oil sample manually, but rather than saying, like when we come back to the example of a human being, nowadays we are running around with these smartwatches and trying to supervise our health, because, I mean, based on the measurements which we do at our wrist over there, we get an early, let's say, alert if something is happening, and then we say, okay, look, a similar, let's say, solution is available. Instead of doing an oil sample once in a year, twice in a year, you're doing and installing an online DGA which measures continuously.
So I install a device which is called a DGA sensor, which is then monitoring the condition of this individual transformer 365 days.
Exactly. Okay. So that means you install it over there, and then depending on the extraction method, depending on the technology a little bit, it will measure 4 or 5 times a day, for example, the gas accumulation within the oil. And this is not a new trend. I mean, we started back a couple of years ago, 10, 15 years ago, when companies tried to adapt a laboratory into, let's say, a smaller housing, which you could install at the transformer. So they came up with technologies like an online DGA system with the gas chromatography technology, or any other, let's say, optical method over there. But these devices are extremely expensive, are very sensitive, and I mean, you've been traveling around the world. You know, I mean, it's like when you look at the transformer over there, it's like it's not like in a clean condition like you're in a laboratory. I mean,
right.
It's like
You have industry applications, or it's outside installed. You have rain, hail, maybe sometimes, or even snow when it's somewhere in the northern or southern area in the world.
Exactly. So, and when you talk about a multi-gas sensor over there, which gives you the additional advantage of not only measuring the values, but also have a certain fault classification specification. But on the other side, the disadvantage is that you have consumables, you have a calibration gas, you have a
different
other
technologies now with
different
this gas.
technologies.
So
exactly.
if I use this, for example, then I always have CapEx costs or OpEx costs, depending, because I need then this carrier gas, for example.
Yeah. And then I ask, okay, look, what is happening when you get an alert now? And I would say the majority of the asset managers are telling me, look, when I get an alert, I go there, take the oil sample and give it to the laboratory.
For a closer look, then I would
assume. For a closer look, you have to measure the breakdown voltage. I mean, you can do a full run analysis. I mean, you can do further, let's say, measurements and analysis in the laboratory, which you can't do at site.
Okay, got it.
So I said, look, I mean, where is then the major advantage of having a high sophisticated device installed over there when you go there and take the sample as well? So what about the idea if you have only let's say, the two major gases analyzed, and if you get an alarm, you take the oil sample and give it to the laboratory?
And which gases would that be, these two major gases?
The two major gases are, in our perspective, the hydrogen and carbon monoxide. Hydrogen in terms of any electrical faults, and carbon monoxide in terms of any thermal faults. And additionally, which are most of the sensors as well providing, is the humidity. I mean, moisture in the oil. Exactly. So, where we are saying, okay, look, the philosophy right now, which is currently changing, and the idea, instead of, let's say, you have a fleet of transformers aging, you would like to extend the lifetime of the transformer, you would like to implement a certain predictive maintenance strategy. For that, you need to know exactly the condition of the transformer. So rather than say, okay, look, 1 out of 100, I'm installing a multi-gas, extremely expensive system over there, saying, okay, look, I will equip the most critical and less critical transformers with a 3-gas sensor. I mean, when I talk about a 3-gas sensor, I mean 2 gases plus moisture. But this is, let's say, the typical, let's say, spelling when you talk with people. They say, okay, a 3-gas sensor, which is then 2 gases, H2, CO, and moisture. And then you have a certain trend analysis, because this is the major point. The advantage is that means when you're measuring now only once in a year or twice in a year and you take the oil sample, as you correctly said, you have a gap in between. And it's too late when you go there and you make the next sample and say, okay, look, if I would have known this issue already 3 months before, I could have acted and I could prevent it. Any severe damage at the transformer. As
you said with the doctor, when you brought the example with the doctor, next time you come earlier, but how you ensured, or how can you be aware of anything if you have no tool or diagnostic method to close these gaps?
Look, this is I mean, the analogy with human being is not that far, because I mean, that older we get, that more often we go to a doctor in order to have a checkup over there, which is typically, let's say, at least what I get recommended even from the company, which is say, okay, look, on a regular check over there, just to know, okay, look early enough if something is happening. And the same thing is nowadays with asset managers. They look, I mean, it's like we have a loss of experienced personnel nowadays. I mean, a lot of people are retiring. I mean, young stuff is coming along.
More of experts in school here and there.
And I talked to a lot of asset managers, and they will say, look, I mean, it's like transformer XYZ. They say, okay, look, this transformer is in this condition. They have a bunch of A4 folders behind them. They know the condition and everything. But nowadays, when you come over there, I mean, it's everything about digitalization. It's everything about automation. It's everything about to know the condition of each individual asset at any time. And there, any paperwork doesn't help me. So that means also, I mean, going into this direction to know the condition and to be capable and able to access this knowledge at any time from anywhere is nowadays let's say the requested solution from asset managers.
This is where the industry is then moving currently, if I understand that correctly. Plus, I have a digital available, plus I know the condition then. So I'm better informed about my individual asset that I have now.
Exactly. And along with that, it gives you the possibility to adjust your strategy. You now have the possibility to do predictive maintenance, getting back from, let's say, a time-based maintenance or, let's say, a failure-based maintenance, which is also even nowadays in certain cases done. But having now the knowledge about the actual condition of the transformers, and as I said, I mean, online DGA, or let's say the analysis of the insulating oil, is one of the key factors in order to make a statement about the quality, let's say the condition of the active part in the transformer, gives you the assurance to extend the lifetime, to work with higher loads without risking the transformer on the other side, to live along with the higher energy demand, what we are all facing, to live with the volatility due to renewable energy. So these are the challenges which asset managers are telling me are currently what they are currently facing, and they are seeking for solutions.
So the new technologies help, for example, to integrate solar, wind, and also these major challenges what the industry is currently facing to, I would say, as you mentioned as well, extend the lifetime of existing transformers, because on the other hand, they need also new transformers for the network to do this new demand from wind and solar. Okay, got that. You mentioned before different technologies, no? How is such a DGA sensor working? Just roughly, Oliver.
Yeah. Roughly, I mean, it's like there are different technologies depending on the system. So typically, it's like that you have a sensor installed permanently over there. Either you have the sensor directly in the oil flow of the transformer. Some are working like with a pump where they are seeking out the oil, then getting it into a chamber. They are extracting the oil, then extracting the gases from the oil. So, and then the gases are measured. This could be an optical measurement, for example, depending on the wavelength. You know what is the gas concentration within the oil. So there are different methods over there. At the end, they all work to a certain extent. But as a asset manager, you have to decide also what is the main advantage for each individual. As I said, multi-gas sensors, they are good. They are for a long time in the field.
But I have a higher investment then.
You have a higher investment over there, and not only the capital expenses what you have on the one hand side, but you have also operational expenses, because they're all subject to wears. They are all subject to consumables, and it comes to the point where I always get into discussion to a point where I say, okay, look, but at the end you're taking an oil sample anyway. They said yes, because I don't 100% rely on them. I might have a quick, let's say, failure and root cause indication, because the failure of I can indicate, let's say, with a Duval triangle, for example. But at the end, I'm giving you to the laboratory. And instead of now spending that much money on a multi-gas sensor, the idea and the philosophy right now is a bit of changing. Say, okay, look, I'd rather go for a 3-gas sensor, having a trend analysis based on the major gas concentrations, H2 and CO, and permanently measure. And if there's any indication of a possible fault, I will take an oil sample anyway and give it to the laboratory. So that there's also a major advantage. That means you save money, and you can allocate and you can retrofit a larger number of transformers. And along with that, you have a safer and a more secure and more, let's say, condition and possibility of a predictive maintenance according to the data which you're measuring.
You mentioned an interesting point. You mentioned the retrofit. So installing the device on an existing transformer which was or is not equipped currently. So this option is also existing for the DGA sensor now.
Exactly. I mean, we always talk about, and our company as well as, as a major supplier to transformer manufacturers, we are talking about new transformers, new specifications, what is going to be the trend over there. But we have a huge fleet which is already installed in the field. That means we talk about more than 1 million transformers which are currently installed in the field around the world. Globally. And we have let's say, an average age of transformers which is about 35 to 40 years old. It's like, if I remember back when I started working at MR, we talked about an average expectation of a transformer lifetime is about 35 years. Nowadays, we talk about 50 years, 60 years, depending on the condition. And that is where asset managers currently are seeking for possible solutions, not only for, let's say, monitoring the transformer, but rather as well any asset around the transformer. Let it be the bushing, let it be the tap changer, let it be the transformer itself, and any asset around. Is it cable box? Is it anything? So by having the knowledge and based on a certain data which you seek from different sensors which are installed at the transformer, it will provide you the possibility to work with these kind of conditions what asset managers are currently challenging.
Interesting, because you mentioned pushing monitoring and all-level indicators when we start from the basic switches on a transformer. All-level indicator, winding temperature, all-level temperature. So we have already maybe not smart sensors, no? So conventional sensors are installed on a transformer. And there is a possibility now to add more things to monitor either a critical transformer closer or an already aged fleet to extend the lifetime, to adjust my asset strategy, or to collect data, which maybe helps me in the future to optimize my strategy also for the new transformers, no?
Exactly, Christian. This is the idea, and then let's say a lot of committees and groups are currently exactly.
You mentioned it, exactly, well known. Yeah,
exactly. I mean, there are a lot of working groups right now working on these subjects over there. How the industry can support of providing intelligent sensors that they are connected directly with the SCADA system. Because I mean, it's like nowadays you have the control center in order to responsible for the network over there. They have the clear knowledge about which transformer they can allocate and shift the load over there. But the asset managers, they are lacking of this information. And there are more and more solutions right now on the market to provide to those asset managers with digital sensors which can be directly and are equipped with a certain communication protocol, so that asset managers have a clear indication and a clear trend and a knowledge about their transformers, about the complete fleet at any time from anywhere. So we talk about on the process level by equipping the transformer with different sensors, and DGA is one of these sensors.
And it's then transferred with the protocol to the SCADA system of the customer, right?
Exactly, exactly. So that he has the clear knowledge, and not only with the control station, but also for the asset manager, who is at the end responsible for the asset, and who has to make sure that these assets are running as long as possible and are capable of carrying as well higher loads during peak time when a certain energy demand is needed.
And not risking anything. When we think about these transformers, maybe in an area where a lot of people live, and then of course you should then of course avoid explosions or any criticality, depending where the transformer is located. Or industry, totally different. If you lose this, then you maybe lose the protection.
Yeah. And when you come to the point of production, when we talk about the loss of a transformer, the one thing is to get a new transformers. And nowadays we know, I mean, energy demand is increasing over there. Transformer manufacturers, all their plants are full till for the next 2-3 years. So it's not that easy to just say, okay, look, I need a replacement. I mean, beside of the money which you have to invest. But when we talk about industrial customers, we talk about a production over there. I mean, the loss, the consequent loss over there which you have. And I talk to different kind of steel plants over there. We talk about $50,000, $60,000, $70,000 per hour what they're losing. Then every single minute is really counting. So, and if you have a system, and if you have a possibility, and one of this, let's say, brick of a complete house over there to get a complete overview about the condition of your transformer is definitely the oil analysis with the support of an online DGA. You can have an early detection of a possible fault. You can act on that. You can take certain measurements in order to prevent any damages on the transformer in advance.
Risk reduction, so I have a better knowledge about my individual conditions. There are a lot of benefits, but I would assume that the global footprint plays also now a bigger and bigger role. I would have also the option, for example, now I take 2 oil samples per year, or 4, no? For example, I install the sensor. Would it then be possible that I reduce it to 1 and just act in case there would be any trending or an alarm coming?
As it is permanently installed over there, and that's a good question, because when we are talking online DGA, of course, I mean, there's some smart questions. Say, okay, look, I just take it over there, and then bring it from one transformer to the other one. The idea is that it is permanently installed. So, and then you have 3, 4, 5 times a day, you have a certain measurement over there.
So it measures even more often per day as I would do it on my conventional way now.
Definitely. Okay. It measures 4 or 5 times a day, and it is even that much intelligent over there that, for example, if it measures a certain increase of a certain value over there, it will then shorten the interval. That means you're not only then taking an oil sample every 4 hours, for example, you're taking then every 2 hours in order to have a shorter, let's say, period of measuring in order to get a better trend over there. And it's not only about the absolute values, it's also about the values at the time. That means if you have a certain increase in a shorter time, it will also give you, even if you don't reach the certain limit, but if you have a sudden increase because of a certain issue at the transformer, you also get an alarm and you can act accordingly.
So it's not only trending. So if there is a peak in any gas, it doesn't matter which sensor is installed.
Exactly.
And then I get also an alarm or information about that.
Exactly.
Oh, that's
and then you can act on that. And when you combine this information now along with other measurements, what you're doing, you know the load current of the transformer, you know the environmental temperature over there, and you take all this into consideration, because a higher load could also cause a certain short increase over there. But having this all in consideration, you are then capable of making a decision based on the data which you have measured.
Combining more information is also nice. So I have another tool in my diagnostic toolbox to get a clearer picture about the individual condition.
Exactly.
You said it already, you're more than 20 years with us. Can you share any project or experience where the solution, the DGA sensor, helped or prevented a catastrophic failure?
Yeah, there was a case when we started NMR with the production as well of online GA sensors, and I was working abroad and I was working along with a customer in the utility sector, and his transformer fleet was already a certain mid-age, about 35, 38 years old, and he was facing here and there the one or other issue. He was taking regularly oil samples, but he said, okay, look. If I have an issue in between the oil samples, then it is too late, because I'm not having this kind of oil samples continuously over there. And but he was also on the other side not willing to invest, and because there's a certain question of a budget for these extremely expensive multi-gas sensors.
So he reached lifetime. Now you mentioned before 35 years. Now
exactly, and he wanted to extend it because the transformer itself, from what he could see, have been in a good certain condition over there.
Okay.
So I said, okay, look, let's start and let's make a trend analysis along with an online monitoring system with an online DGA. But rather than going for an extremely high expensive multi-gas, we take these two, let's say, key gases which we think are the most critical gases, H2 and CO, which happen in case of an electrical fault or a thermal fault over there. And he agreed to install these. And at one time he called me and said, okay, look, and he said, thank you, Oliver. It was a great idea. I said, I have to thank you giving us the chance to make this project together. And so I said, no, that's was not what I was meaning. I was saying, I really had an incident right now. I had a sudden increase of H2 value. I acted accordingly, took an oil sample, and we could prevent a severe damage on the transformer, which was, the root cause at the end, which we figured out was partial discharge over there. So, but as a matter of fact, is
so the sensor was helping him to prevent a further catastrophic failure. Oh,
exactly. So,
unbelievable.
I was happy. Usually you have an endurance. Nothing else. It is over there to have an endurance. Also for safety and know the condition. But in this case, it was really the matter of fact that it was acting, and he could prevent, and he could he could act accordingly. And he confirmed this kind of philosophy rather than installing one or two multi-gas sensors on the most critical transformers, which is still a good idea. It's like, if you have certain critical transformers, massive criticality, but rather than to say, okay, look, all the other transformers I cannot equip because the price is too high for me, rather than go and make a 3-gas sensor over there, install it, and you have the major gases which you're measuring. And in case of an alert over there, you can act accordingly.
Okay, so we have the different technologies. So it's still a good idea for here and there when I have massive critical transformer HVDC, for example, to install these multi-gas sensors. But when I'm then responsible for, as an asset manager, for 500 or 600 transformers, then I still have the option with the DGA3, for example, which you mentioned, to install it on much more because of this price benefit, what I would gain.
Exactly. I mean, we talk about a price difference. I mean, it depends on the market, but at least 5-6 times it is more. And yes, of course, you have advantages with a multi-gas sensor. You can have, let's say, a fault classification. That means immediately you can allocate this, what might be the root
in the
cause.
dual triangle.
For example, on the other side, when you talk a transformer fleet, and you mentioned it, I mean, energy demand is increasing. More and more transformers are installed, needs to be installed. We have a decentralized power supply. That means more transformers needs to be installed. And if you would like to equip those with intelligent sensors, you have to find sensors which are also let's say, attractive from the pricing, and gives you on the other side the same assurance and same advantages by knowing these two major key gases are measured, and giving you an early detection and an early warning in case of a possible failure.
Makes absolutely sense. Is there, from your side, any advice or a hint what you could give asset managers, service managers around the globe?
Look, what I can tell you is like the feedback what I get from them when we talk with these different, because they a lot of them know already what they're doing, and what I see as well is a certain trend as well to know the actual condition of the current, to know the actual status of the transformer. I think this is the most important thing when you start implementing certain monitoring systems over there. You have to start from a certain basis, knowing this is the condition. And then based on that knowledge, you start then installing it. Because it's different when you have a new transformer, you're installing an online DGA, or you're installing it after 30 years, because then the transformer has a certain L-ring process over there. You need to know the condition, because otherwise a certain guessing might be there. So that means you have to have a certain basis.
It can be individual, the condition.
Yes.
Maybe same manufacturer.
Yeah.
The one is indoor, the other outdoor, 100% loaded, the other one just with 80. So I really... just to understand it right now, you mean the individual condition of the individual
transformer. Once you have this, and you have let's say you implement a certain asset management strategy over there, I think, and this is what I get as well as the feedback, is one of the let's say starting point, the major let's say where it gives you the best benefit already from the beginning is an online GGA over there, and more and more. Let's say digital sensors, or let's say intelligent sensors you can install over there, extending, for example, even bushing monitoring. You can make those let's say existing sensors like oil level, oil temperature. You can make them intelligent in terms of that you can have everything transmitted as well via a protocol, for example, to know the condition. You can even retrofit, or you can even monitor an on-load tap changer. Even there it is possible. So with different possibilities. If it is a moisture sensor, if it is a DGA sensor. So each individual asset has a certain, let's say, possibility of extending and retrofitting.
So the conclusion for me would be then, first, I should know the individual condition of the transformer. And as a starting base, I have the option for the DGA sensor. There are different technologies available. If I'm responsible for a huge fleet, I have the option to invest with the DGA3 sensor, because I can install it on 5 transformers compared to a multi-gas, which I can then from the same money install only on one. So this is a very good hint. And good to know that we have to know the individual condition, because this can be very, very different around the globe. I think I gained a lot of information today, a lot of interesting insights. So thank you, Oliver, for coming today and give us a lot of interesting insights, I think, especially from that project which you mentioned before. For me, it was a pleasure to have you here. To our followers around the globe, thank you for watching our podcast. leave a like, leave a comment. If you have any questions or suggestions on topics, reach out to us. Specifically for the topic, you can also reach out to Oliver. Thank you very much, and stay tuned for more updates from the power behind power.